Hello and welcome to part 9 of the ongoing AS and A-Level Python series. And in this episode, we're going to be looking at operators. So Python follows the PEMDAS rule, right? And PEMDAS simply means that parentheses are going to go first, followed by exponents, then multiplication and division, and addition and subtraction will come after all those operations have been taken care of. So maybe for the purposes of this video, let's actually declare two variables. Let's have num1, which is 500, and num2, which is 760. Then we might actually need to have another variable called name, and we'll set it to, actually let's make it name1, and we'll set it to Dell, right, as in the computer manufacturer, the company. Then let's actually have name2, and we'll call it HP. Right, these ones we'll need them for the last section of the tutorial. But now for the first section, let's look at the arithmetic operators. So these ones, they basically do what you'd expect, right? Arithmetic operations. Maybe what I can do for, let me make my numbers small. So maybe let me use 5 and maybe say 14, right? And I think that should do it. So let's actually look at each operator in 10. So let's go with num1 plus num2. Then we can also just copy this line and paste it a couple times. Then we'll come and say num1 minus num2, then num1 divided by num2, then num1. Actually for this one we might want to make it num2 modulo num1. Then for this one, for the multiplication, we might as well just take it as it is. Then for this one, we might just want to say num2 raised to the power of num1. Then for the last one, I think we also need to have num2 going first, so we have num2, then num1 over there. Alright, so let me just go ahead and print this so that we can actually get the full context of how these arithmetic operators work. So let's call the Python interpreter, then let's also call the name of the file that we wanted to interpret. So it's operator.py. Actually it's operators.py. So there we go. Let me just play the screen. Let me call that one more time. Alright, so here we go. So in the first instance, you realize that as you'd expect, you get the sum of num1 plus num2. That's what we have here, 19. Then in the second instance, we're subtracting num2 rather from num1. So we get minus 9 as you'd expect. Then in the third instance, again, we're dividing 5 by 14. So we get that particular value there. Then on line number 12, right? We're actually getting, so this is 1 2 3, so this is the fourth. So you realize that we are dividing 5, dividing 14 by 5, is it? But I want you to notice that the value that we're actually getting is the remainder of dividing 14 by 5. So you'd realize that 14 divided by 5, it means that 5 gets into 14, that's 2 times, leaving a remainder of 4. So that's why we're getting that particular value there. So the percentage sign is it's otherwise called the remainder operator. So it's going to give you the remainder of integer division, as it were. Then the multiplication sign, again, it works as you'd expect. It's simply multiplying 14 by 5. Then the exponentiation sign, or the way you exponentiate or you raise a number to a particular value, is you make use of the double asterisk or the double stars. And in this case, we are raising 14 to the power of 5. So that's why we're getting that particular value of 537,000 and some change there. Then lastly, we are using the flow operator. This one is called the flow operator. The flow operator is two forward slashes, right? So what this does is that it's actually going to divide the integers, and or rather divide two numbers, and it just takes the integer part, and it's going to discard the remainder part, or it's going to truncate, as it were, the integer part. So in essence, this is actually the opposite of the modulo operator, right? Because remember, the modulo gives us 4, which is the remainder, right? But this one, it actually gives us the integer, or the how many times a particular value gets into a particular value, and if it's going to leave a remainder, it's just going to ignore the remainders and just give you the integer part. So that's just about it for the arithmetic operators. Let's move on to look at logical, or the comparison operators. So I think we might have actually looked at these in the previous episode, but for the purposes of this video, I'm just going to look at the is and the is not. So let me print we have name 1. I know we have name 1, and we have name 2, right? So in the first instance, I'm just going to check if name 1 is name 2, and in the last instance, I'm actually going to check if name 1 is name 1. So if I go ahead and run this and down in the console, you realize that in the first instance, I'm going to get false. So this is actually true, because we are saying that name 1 is not name 2, right? So you realize that the answer that we're getting is false. We are checking to see if name 1 is name 2, and we know that is not true, so that's why we're getting this value of false right there. Then in the second instance, on line number 19, we're checking to see if name 1 is name 1, so it's actually giving us a value of true. So the reason why I introduced this concept is these logical operators is because in as much as they work the same way as your relational operators in the previous episode, these ones, they are particularly for objects. And I know we haven't really touched the concept of object-oriented programming as of yet, but maybe just for context, right, you just need to realize that strings are objects. So that's why we are making use of is and is not. So you can actually do something like name 1 is not name 2, right? So if we actually run that, we should get true is the first value, and you can actually see that name 1 is not name 2. That's true, because name 1 and name 2, they are two different strings or objects as it were. So in addition to making use of the logical operators that we saw in the previous episode, you can actually make use of the is and the is not keywords to check for the equality of objects, because objects, as you shall come to realize, they are reference types, they are not primitive types. Then lastly, we also have the Boolean operators. You'd expect to have an OR gate, an AND gate, and a NOT gate, as it were, right? So you actually have that in Python as well. So for instance, let's say if we wanted to check or make a decision to see if name 1 is equal to name 2, right, we could actually say something like this. Let's try and say, let's first declare a variable. Maybe let's call it company, and let's set it to maybe let's go with ASA. Then what we can do is to check if company is equal, actually let's make use of the is operator, is name 1 or name 1 is name 1. Then let's say we want to simply print this runs if either one of the above conditions is true. Right, so let's actually demonstrate that concept right there. So let me just open the terminal and run that. So you realize that we get that statement which is supposed to run if either one of the above conditions is true. So this would work as you'd expect, like your typical what or gate, as it were, is it? So it checks to see if this one returns a value of 1 or if this one returns a value of 1. So if either one of these actually returns a value of 1, it means that the code that follows is going to be executed. Then we can change this to an end, and you should realize that we shouldn't get output, or rather that line is not going to be output, because the AND gate, the way it works is that it expects that both conditions should be true. So in this instance, company, where we have the value of ESA, is not the same as name one, in which we have the value of Dell. So those are two different objects, so it can't really execute the statement because already it has returned a false in the first logical comparison right here. So even if this statement is true, right, and this one is false, we are not going to have this line executed because it's going to be ignored, because that's how the AND gate works. Then of course we do have the not operator. I think we saw this one in when we were checking for the equality of strings, right, when we made use of the is not right here on line 18. So basically that's how it works. It's just going to negate a condition, as it were. All right, so for instance, maybe if we were to come here and change it to is not right, you'd actually realize that we are going to have that line execute, because that Boolean expression, because we realize that Boolean expression evaluates to true, so we get that line printed down there in the console. So I think that's just about it for this episode. I'll see you in the next one.